Simple and emotional harmonic motion. Not gonna lie, I think physics is mad stupid. But I realize that waves might matter even if physics is stupid, so here's my explanation to why that is. Let's take a spring, a cold metal inanimate object that describes human existence. If you consider Hooke's law, we know that the force acting upon a spring is equal to the negative spring force constant times displacement. And since the spring force is constant, then what we can do with this equation is arrange it so we can have one known value equal two unknown values, the force and the displacement. This is really valuable because we can describe the relationship between force and displacement as inverses of each other. So as a force pulls on a spring and pushes it into the positive x direction, then the displacement will compress and go in the negative x direction. And if a force pushes in the negative x direction, compressing the spring, the displacement will oppose it and increase and expand in the positive direction. In an ideal system, these counteracting forces will go on forever. Displacement will overshoot in the positive direction, and to compensate, will overshoot in the negative direction. This graph in reality is very trigonometric. There are battling forces trying to approach an ideal line, and since there's overshooting, it'll never reach this equilibrium distance. But I'll spoil the philosophical part. Force doesn't explain spring and why it is doing what it's doing. So let's consider Newton's second law. Force equals mass times acceleration. Here we can replace F in this ratio and replace it with mass times acceleration. But this isn't really helpful in explaining position. So fortunately, acceleration can be described as the second derivative of position. If we derive acceleration down to velocity, dv dt, and then again, we can find position as ddx ddt. Now we can apply Hooke's law together and find that force resultant of displacement is actually equal to mass times the second derivative of that displacement. This is why I hate physics. Because we can move on from this equation like nothing happened because it's just numbers and ratio and logic and wait, I'm going to finish my math problem. But actually, I think this equation reveals some emotional trauma the spring experiences. See, this side describes where X is. And if you want to get philosophical, where you currently are in your life. And this other side, acceleration, describes how fast you want to change the place where you are. If you look back at this trigonometric description, when you're at your crest, you're at your peak. You don't want to change very fast. You want to linger. The hill plateaus. At your very peak, your velocity is zero. You're motionless, completely still. You stay there for as long as you can until you have to ground yourself. And that makes total sense. If you want to look at another emotional equation, kinetic energy equals 1/2 mass times velocity squared. At your peak, your velocity is zero. You literally don't have the energy to move. Why would you? Except there's this other emotional equation. Potential energy equals 1/2 mass position squared. When you're at your peak, you don't waste your energy to move because you're at your highest position and you have your most potential. You've reached a glass ceiling until you start moving again. The more you move, the more potential you lose as you go down, decreasing your potential energy while increasing your kinetic energy. When you're at your equilibrium point, you have zero displacement, which means you have zero potential. You're the most disappointed you are with yourself and what you believe you can achieve. And if you look at it mathematically, when you're at your equilibrium point, how fast do you want to move from that point? Your velocity is actually the steepest. If your position is at your equilibrium, the other side of the equation is telling you desperately want to leave the state. And in this case, the direction you're heading towards is literally downwards. You reach your lowest. You don't want to change. It's hard to move. Your kinetic energy is zero. But there's a bright side. For your potential energy intrinsically does not care if your displacement is negative. Life doesn't care if you're at your lowest point. The value of your position is squared. So even if you're at your lowest, you actually reach your highest potential again and shoot upwards. So while we describe oscillations as a need for order in which every force that needs to have a restoring force, when you reach equilibrium and find order, your life is moving its fastest, trying to go into a direction that maximizes your potential. There's nothing romantic or peaceful about reaching equilibrium. If you consider French philosopher Albert Camus in his essay The Myth of Sisyphus, he describes that life is void of meaning. That absurdity is the fact that humans will continue to search for meaning in what is meaningless. In the last chapter of his essay, he rationalizes this intrinsic meaninglessness with the myth of Sisyphus, a man who escaped death and was subsequently punished by the gods. Every day, Sisyphus must roll a boulder up a mountain, and once it reaches its top, it must roll down for him to have it roll up again. Camus is puzzled that a man who escaped death and challenged the gods would remain fixated by this meaningless punishment. Like reporting to school or work or family or society, humans are punished by cyclical repetitive tasks that are also meaningless. But Camus wonders that once Sisyphus realizes this, he will no longer roll the boulder and will be freed of his punishment. In this case, he's freed from the bounds of an equilibrium. How fast he's going and where he's going is not determined by a line, a sense of zero. Except Sisyphus never leaves his punishment. When he's at the bottom of the mountain, all he has is hope he can finish his task. And once the boulder rolls down, he's disappointed by the struggle and revolts against the status of life, so he decides to roll the boulder up again and restore his hope. So you, like Sisyphus, never want to reach equilibrium because your hope will overshoot until you face adversity, which will inevitably ground you until you hope again. And so this is what this equation reveals. ddx ddt equals negative kx over m. What separates you from where you are, your position, and how fast you want to get somewhere else, is this negative force constant divided by mass. In a spring, both of these variables are constant. The motion is simple, and the way it moves is predictable and harmonious. But in a human, your mass is constantly changing, philosophically. Your matter, all the electrons, protons, neutrons, cells, and organs that work together to make you feel, love, create, inspire, and live, that's all changing. And the everyday forces you experience, too, are changing. And so how fast you want to change, which is dependent on where you currently are, what makes you you, and what forces you're dealing with. It's not as simple or harmonious, but it's definitely some type of motion. And so that's why I think this equation's pretty neat. How a spring can tell you everything you need to know about life, why there's something to hope for, and why there's a reason to keep on living. But physics is freaking stupid, so the end.